Well, now we'll do worksheet 3B. And so you get yours out, and here's mine. And it says if a stack of $5 bills is worth $75 billion, what is the height of the stack in kilometers? Assume each bill is 0.2 millimeters thick. So let's see, we've got, this is 1. We've got 75 billion, so that's times 10 to the 9th dollars. And each bill is 2 millimeters thick. So we're talking 0.2 millimeters per $5. And then we've got to convert this to kilometers. Okay, so there's 1,000 millimeters in a meter and 1,000 meters in a kilometer. Let's see what we have now. The meters divide out, the millimeters divide out, the dollars divide out. 5 goes into 75 15 times. And so when I carry out the multiplication, I get, oh, yes, we get 0.2 times 15 is, 2 times 15 is 30, so 0.2 times 15 is just going to be 3. And 3 times 10 to the 9th kilometers over, and we've just got 10 to the 6th downstairs, so that equals 3 times 10 to the 9th times 10 to the negative 6, bringing that factor downstairs upstairs. We change the sign on the exponent, which equals 3 times 10 to the 9 minus 6 is 3 kilometers, which equals, and that's good in scientific notation, or 3,000 kilometers. How did they want that answer? Let's see. Oh, either way will do. Okay, so that's 1. Let's get 2 out of the way. And 2 says, convert 2 times 10 to the 9th from scientific notation to ordinary notation and write its name. Well, 2 times 10 to the 9th equals 2, and now we're going to put 9 zeros to the right of the 2, and that equals 2 billion. L-L-I-O-N. There we go, 2 billion. Okay, 3. Can we get that? Yeah, 3. We've got to write 0.00067 in scientific notation. Okay, so we always have 1 digit to the left of the decimal and whatever else to the right times 10, and we move that decimal over 1, 2, 3, 4 places, and since we're going to make it -4 because we made this value larger, so we have to compensate by making this value, this factor of 10, smaller. So that's 10 to the -4th. Let's see, so do we have time for one more? Yeah, 10 to the, let's see, number 5. Multiply 2.2 times 10 to the 5th times 6.5 times 10 to the 8th. Show your work clearly, express the final answer in scientific notation. Okay. So we have this is, oh, I beg your pardon, we're doing 4. We're doing 4, yeah. Suppose you add 10 to the 6 plus 10 to the 37th. Okay, 4. 10 to the, I beg your pardon, 10 to the 67 plus 10 to the 37. And what approximately is the answer? Well, the answer is going to be 10 approximately, 10 to the 67. And here's why. Will you agree that's going to be 10? There's going to be a 1 and 67 zeros. 67. Here, we're going to add it to a 1 with 37 zeros. Look at the difference. There's 30 zeros separating the ones for each of these numbers. So when you round that thing, it's still going to round up to 10 to the 67th. This, by comparison, this 10 to the 37 is minuscule compared to the 10 to the 67. So that's where we get 10 to the 67 when you add them up and round. Good. We'll stop right